So in this problem, we are given an open loop transfer function, and we need to find the phase crossover frequency. Okay, so how do we do that? Well, so the phase crossover frequency occurs at the angle of the open loop transfer function at j omega equals 1 negative 180. So this is really the key of solving this problem. So if we put step 1, put s equals j omega in this transfer function, so that would give us hg of j omega equals k times 1 plus j omega divided by s squared is going to be j omega squared times 1 plus j omega divided by 10 squared. So now I need to find the phase equation for this. So the step 2 is step 1, this is step 2. So the phase equation is calculated as the following. So h g of j omega equals, so we need to look at the denominator first. Okay, so since this is the second degree, we multiply 90 degree by 2, which is negative 180 degree, and I'm writing negative because this is in denominator. And similarly, since I have power 2 here, this is 2 raised, this is the degree of 2, that's why it is going to be negative for the denominator, and 2 times tan inverse of the angle omega over 10. Now I am ready to go to the numerator here, which is going to be plus tan inverse omega, right? And then remember in the beginning I said this is where the phase crossover frequency happens, so we can simply write equals negative 180 degree for phase crossover frequency. This is what we do. So in the next step, we can cancel this and this 180 because they are same. So now we're left with this formula, this expression, which is so tan inverse of omega minus so tan inverse of omega over 10 plus tan inverse of omega over 10. So we need to recall something here. So recall the formula for tan inverse x plus minus tan inverse y equals to 1 minus this is going to be x plus minus y over 1 minus plus x over y. So in this case, we are given the positive. As you can see here, this is positive. So this will, I'm going to use x plus y over 1 minus xy formula. Okay. So that is basically going to yield me, give me something like this. So this equation here, so this will give me x plus y is going to be omega over 10 plus omega over 10 will basically be on 2 times omega over 10, so I can write omega over 5 over 1 minus omega over 10 times omega over 10, which is omega squared over 100. And here I have tan inverse omega. This formula is actually going to be tan inverse of that expression. So this is going to be tan inverse of whole thing. So that means, so I have uh, tan inverse of omega minus tan inverse of whole expression. So now in this case, I will have, and this is my x, and the whole thing has my y. And since I have negative, I'm going to apply the one with the negative formula. So that would be omega minus omega over 5 divided by 1 minus omega squared over 100, and here will be some number because I will have 1 minus x times y, and since I know that this is going to be equal to 0, I'm not going to calculate this because this is basically will be 0. So let me just focus on the numerator part. So that would be omega minus omega over 5 times 100 over 100 minus omega squared. Okay, so that is, I can cancel 5 and 100 for 20 times, and so that is basically going to be 100 omega minus omega cubed minus 20 omega equals 0. And so this is going to be so omega cubed equals 80 omega. I can say omega squared equals 80, omega equals plus minus square root of 80, and if you put that in calculator, what would that be? So that would be 4 square root of 5, which is close to 8.94. Okay, so this is my phase crossover frequency. So this is my phase crossover frequency. So this is how we find the phase crossover frequency. This goes here, and this is my answer. Okay, and I also did solve this problem in MATLAB so that I can just demonstrate it. So here I have I just define the transfer function and just use the body plot to plot the graph, and I have this margin function. And the clean thing about the MATLAB is I can simply type WCG for the margin function, and that would give me the answer, the phase crossover frequency. So this is how we find phase crossover frequency, both by hand and by MATLAB.